Good afternoon, everyone. First, I want to thank the organizer to give me the opportunity to present and share our work on iron biofortification at this meeting. As it's mentioned, the work that I'm going to present today is engineering the IR64 mega variety to reach 30% of estimate average requirement of dietary iron in polished rice. And I think Dr. Nizizawa already mentioned that micronutrient deficiencies affected more than 2 billion people globally, and it's mainly actually on iron, zinc, vitamin A, and iodine. And in the country, we can see here in Asian and also in African, South American countries that it's still a major problem, and it's quite some of the countries overlap between iron and zinc. If we look at who is actually consume rice the most, many of these countries still consume more than 120 kg per capita per year. So if we can improve the baseline of iron concentration on rice, it would be a potential sustainable solution together with other approach, like of course the first attempt should be a diverse diet, next and then with supplementation and chemical biofortification. But that's one of the major push for us to work on iron biofortification. And the main target of this problem is actually women and children, because children, it can cause the mental development problems and maternity as well, although it's also affected men for the efficiency on production work. And if we look at this estimated average requirement of iron for non-pregnant, non-lactating women is just slightly below 1,500 microgram per day, and for children is about 5 microgram per day. And assuming that 90% of iron is stable after processing, this iron is pretty stable. And there has been a study on the human feeding assay on breeding line of iron. It shows that average of the bioavailability of iron in rice is about 10%, and can be up to 20% on the deficient. So based on this, all these figures, the nutritionist said about that if we just cover the 30% of estimated average requirement, it would be around 13 to 14 part per million. Unfortunately, most of our popular breeding line is about 2 to 3 part per million. So the homework is to increase from 2 to the 13, and if you remember yesterday from the presentation, is in the publication so far the highest is still not very high, and it was about 4 yesterday in this field. So there were effort still has to be done on this, and for zinc is from 16 to 24 part per million. So our product concept for the transgenic breeding is we want to reach this 13 ppm, and the copy number and molecular complexity of insert must be simple for deregulation purpose. Then an iron measurement, it has to be measured by the second lab, or for us is we use the weight analytical laboratory part from IRRI, because of a little contamination would already change your result, and also milling is a big problem if you don't mill it properly. And also we want the field performance indicates that agronomic and other characteristics are relatively comparable with the wild type. Our approach initially is actually started before I joined IRRI. It's on soybean and rice ferritin into IR64 mega variety with endosperm specific promoter. And then we also add this overexpression of rice YSL2 under sucrose transporter, following the work published by the group of Professor Nizizawa. Sorry. And but we also use the thyroidoxin promoter, and this actually you can see in the poster. But my presentation, I will mainly stress on the overexpression of NAS2 under constitutive promoter and Cypher H1 under endosperm specific promoter. And we also pyramid both, and I will just show you what make us decided to also use NAS2. For this work, we produce more than 5,000 transgenic events. Okay, the platform that we use is just indica semi-high throughput transformation using the immature embryo, and we actually fix the homozygosity at the T1 generation to accelerate by using the primer based on the primer set, the flanking sequence. Why that we decided to keep using ferritin is because ferritin is a unique iron storage molecule, and with a theoretical binding capacity about 4,500 iron atoms per molecule, and also very important that it has been published in many publications. It said that it well absorbs in humans. In soybeans, actually one of the main sources of iron in the vegetarian diet. But it also plays a role in iron detoxification, which is good and for this purpose, but it's challenging because it can also limit your possibility to increase iron. Okay, just very shortly, at that time we comparing different soybean ferritin here and rice ferritin promoter. And if we look at this quantitative analysis of the PCR analysis here, the transcript, you can see that we can actually get a very high expression, and also the protein expression is also higher, up to the 6 times here, but the iron is not really increased so much. And what we got is a maximum is 6.8 microgram per kilogram, despite of significant increase. But interestingly, the activation tag in the group of gene on. So we decided to add this approach in the ferritin and also change the strategy a little bit. But what we learned is that soy ferritin is actually better than rice ferritin for this purpose. So the nicotinamide is iron chelator and is a low molecular mass metal chelator with a high binding affinity. I think yesterday it has been mentioned too. And it's a precursor of deoxymucogenic acid. And slightly different from the approach published by the Masuda et al., that we use rice nicotinamide synthase gene instead of barley NAS, and we use the NAS2 instead of NAS1. And with Alex's work, we decided not to use the 35 as a double enhancer because we don't really want to have a very, very high expression of NAS. Okay. So the construct is actually that we also change the promoter driven the sulfur. So that we have tested, this is also another gluteline promoter, and we have tested by the fusion of gas here that is quite strongly expressed during the embryo development. So this construct has both genes in it, and we produce 246 transgenic plants for using this, and also sulfur only with this promoter, and OSNAS with 35S. And the pre-selection that we conducted is using per-Prussian blue staining, and then after that we did southern to get only on this highly stained iron. The only thing that with the NAS, the highly stained is only few of them have is actually only one of this one, but we still have more plants there that has one single copy. And at the same time, because this is for product, we also look at the beyond tDNA border transfer to make sure that this event is a clean event. But then we are very excited that at least we got like 12 here, 11 ppm, this is on screenhouse, and 18 part per million for using the 2 genes approach. And initially, if we can just get it with a 1 gene approach, of course it would be more simple for the regulatory purpose. And majority of this transformant doesn't have the beyond tDNA border sequence, only a few of them did. If you look at the staining, this is just example of one of the staining. It was also in one of the poster here on this one of the higher events here, a work of Perry. We can see that most this iron is actually a lot of iron is in the suballuron layer, so this layer would be gone after polish, but this layer would retain after polishing. And the protein analysis shows also the increase of 7 to 9-fold expression. This is also in a poster here, and compared to the non-transgenic IR64, this is a different, just showing different events. The same thing, the NAS2 expression is also in protein here increase. Not at this very high level, but it did increase. And one of our hypotheses, most probably it's because of the role of the MA, mucigenic acid, is actually accumulate in the seeds. And if we look at the expression of in the leaf, as expected, because NA is a precursor of DNA, all these two genes is actually expression increase, and strongly correlate with the expression of NAS2. The same thing with the OSNAS NAAT1. Then we send the sample to the Australian metabolomic centers, and then we on the most promising events, and these you can see here. This is the concentration of the NA is increase in the events that having two genes here, and the same thing with the DMA, and this is the both zinc and iron is was improved, elevated actually. And on the one of the selected event, we decided to look on the panel of iron acquisition genes. In this event, on the different stages during embryo development, first the expression was checked in the milky stage, DAO stage, and the mature. And this is the transgene expression of the NAS2, and this is the expression of SOIFER, because SOIFER was actually endosperm specific, so we don't see it in the flag leaf, but we saw the expression of the NAS. And also this is the expression of the SOIFER. Interestingly, that from this 29 iron acquisition gene, there were the gene involved in the translocation here, the YSL4, YSL15, and YSL18, and is actually increased strongly in the milky seed. So I think most of the translocation maybe happened during that stage, even though it's not expressed in the flag leaf. Okay, so then we conducted field trial at IRRI, and it was completed last May with 4 replicates of different events. And actually now, currently, another field trial is ongoing in Colombia. And we polished the seed. The seed is highly polished. Is a little bit maybe over polishing, because we want to be very sure that it is there is no iron contamination because of the brand there. And we were very excited that we got the first result from the IRRI analytical lab, and we sent the biological replicates to the lab in Adelaide, and we saw, even though there was a reduction from 18 to here is about 11 part per million, we can still get a very, very good, almost reach the 30% EAR. And in the some subline, actually, it was there was sublines who shows up to 13 ppm. And here, the 2 events actually showing quite high, as almost reached the expectation. And I think this is the highest iron concentration that has been published so far in the field condition. And zinc concentration on those events that has the NAS gene also increased up to around 50 part per million. But as mentioned yesterday, we also didn't see any increase on the cadmium concentration in any of this line. Okay. In summary, incorporation of Cypher H1 and NOS2 genes significantly increased the iron concentration. And I think I have mentioned the other time, and our bioavailability assay will be conducted in collaboration with Reglan. I just want to just give acknowledgement for the people that has been work on this project. Norman, Lena has been, and Prabjit has been working on the protein analysis, and this Lena, Marie, and Gina is working on the transformation producing this 5,000 events, and Perry and Peach is working on the gene expression, Che working on the YSL approach, and Miko is looking after the field trial with Lena. And we have a lot of this work has been done by Rudy Trijatmiko, and the earlier ferritin work was done by the past member Susanna Poletti, Philip, and Sylvia. And our collaborator is Alex Johnson, James Tangulis, and now Konizuzawa and Hiromi Nakanishi for the YSL work. And Joe Tome, Laura, and Jaime is looking after the field trial in SIAD. And we are actually submitting sample now to Cornell for the bioavailability, I think with the financial support from the Harvest Plus Bill Melinda Gates Foundation and USAID for the Transformation Platform. Thank you.
Thank you. We have time for 2 questions. Yes.
Okay. So I am surprised to see that the expression of OSNM5 is increased maybe 10 times.
Expression of?
OSNM5. Yeah, and OSNM5 is quite high. So I am afraid that because this is a cadmium transporter, so are you looking for the cadmium concentration in the grain?
Yeah, but this is in the, not so much in the seed. We look actually all the cadmium content, and it's below 0.1, and none of them show even a little elevation.
Some more questions? Yeah.
Here that I actually show, this is the control, and this is also, they look pretty normal. This is all these different line. There's 274 is the highest expression, the higher iron content. We don't really like a darker seed.
Any more questions? So I ask one question. Have you looked at the absorption? Because since you express high ferritin from soybean, right? Yeah, absorption, maybe in vitro. Is that improved as well?
We are now currently actually work with Cornell, so they are going to do the Keiko assay for the bioavailability, but Keiko is just approximate, and then we already increased the seed for poultry feeding trial, but we need 50 kg per, so that's why we last 25 to 50 kg per event. So we multiply, and we are actually just sending them 2 days ago.
Yeah, you have to multiply many kilos for human.
Yes.
Human trial.
Yes, but both ferritin has been widely published to be bioavailable, and I think NAS2, the work of Jean An shows that it is in the case with the mouse feeding trial, it was also bioavailable.
Okay, so thank you.